The next chapter is called decision trees or classification and regression trees. CART, CART. So it goes by the short name decision trees or CART, classification and regression trees. Now the goal of classification trees is to come up with a classification for a record by following a particular set of rules which are developed based on the predictors. So here is one possible rule, one example. Suppose if the goal is to classify a banking record, okay, a potential customer, if we make an offer to that customer, will the customer accept the credit card offer or will not accept the credit card offer? So we start with, suppose if we have a rule, something like this, okay, if income is greater than 92.5 thousand and education is less than 1.5 level, okay, here 1 is I think high school, 2 is college and so on, and family less than or equal to 2.5, okay, which is in between 2 and 3 children, so this will be like 2 or less, right? So this is a kind of a rule. So if this is so, then classify the observation as class equal to 0. That means the offer will not be accepted. Okay, so that would, finally gives you a decision. Okay, when you go through the rule, finally gives you a decision. So so this is the basic idea behind decision trees, or so these are the names: CART, decision trees, or just simply trees. And the rules that we, an example of which we saw just here, is represented in terms of tree diagrams. That is the reason why it's called decision trees or simply trees. So an example of that is something like this. So you start from the top. So you divide the data set into two parts based on the rule here at the top. So we have 114.5 for income, so less than 114.5 this way and greater than 114.5 that way. Okay, and then you go to the next level. Okay, there is another rule based on another predictor. Okay, and then if you go this way, then the tree comes to an end, which means that you have a decision you make. So here the classification is class equal to 0. Okay. If you go this way, there are further levels of rule that you have to evaluate, and then you keep going until you get to the green rectangle. So green nodes are the terminal nodes that give you the decision. So these terminal nodes give you a decision of class equal to 1, and these give you a decision of class equal to 0. So some branches are short, some branches are really long. And also notice that a given predictor may appear more than one time in the course of the decision tree. So the key ideas are you recursively partition the data. So you start from the top, right? So here you are partitioning the data into two groups, this way and that way. So you have one group of observations here, another group of observations here. And then you break it down into further two groups, further partition into two groups, and then further partition into two groups, and so on. So that's what we mean by recursive partitioning. And we keep doing that until we achieve maximum homogeneity within the new part. So you keep doing this until you have a maximum level of homogeneity. Here, apparently, all the observations that came here were all class equal to 0. So that is complete homogeneity. So there is no further branching is necessary from this rectangle. So here, the class is not all 0 or all 1. So there is some impurity. So we needed to do further branching. So until we get to maximum level of homogeneity, you keep branching. And there is a danger when you look for perfect homogeneity, in which case you will really be modeling noise and not the signal. So you have to be careful with that. We'll have more to talk about that a little later. So the idea is to keep recursively partitioning the data until we get maximum homogeneity within the class homogeneity. And then we have to prune the tree, simplify the tree by pruning peripheral branches to avoid overfitting. Okay, so we'll talk more about that later on. So these are the two key ideas. You keep branching, partitioning the data further and further, and then you fall back a little and prune the tree to avoid overfitting.